Kind of the most common question, sorry, that's the wrong color. The first question, a fraction question that most students get is something like this. Do you remember how to add fractions with unlike denominators?
Mm-hmm.
Yes, yes, no, maybe. I'd say that one more time. Just did.
I guess I can use this. Okay, ready.
Okay, so this is the common, the most common questions, like adding two fractions, 1/2 and 1/3. The answer is not 2/5. You don't just add the tops and add the bottoms. Do you remember how to do this, or do you need a sample problem for us to work on?
Don't you have to change one of the numbers?
Both in this case, both bottoms you have to change because they've got to be the same.
Yeah, it's the bottoms you change.
Yes, so the new bottoms here will be 6. And one of the ways you can get that is just by multiplying the two bottoms together.
Because 6 is the first thing they both go into.
Yes, it's called the least common multiple.
And so the lowest thing they both divide into evenly.
Exactly. That's exactly what it is. So you have to figure out what number goes on top, meaning how do you go from 2 to 6?
Don't you take I think it's like you take whatever it would take for it to add that number, like 3 times 2 would be 6 and
Exactly.
2 times 3 would be 6, and then you would times the 1 by both of those things.
Exactly. So it's 3/6 and then 2/6. And because the bottoms are the same, you just keep the bottom.
Yeah, so it would be the 5/6.
Yes. Okay, so let me give you one like it now. Let's try another one here. How about 2/5 plus 2/3?
Two times 5.
Can you tell me what the bottom would be so I can just make sure you're on the right track?
15.
Yes.
And just multiplying the tops, so it would be 10, and then the second one would be, no, it would be, because it's 3.
Good.
So it's 9 over. The other one is 5, and then so it's 9/15 and
Perfect.
plus 10/15.
Yeah. What does that result in?
Oh, that'd be 19/15, and then wouldn't you change that into mixed?
Well,
Or, I
kind
mean, you
of
don't have, you'd have to,
it's
right?
I believe this would be how it would be presented on there. I
Yeah,
would
I
need
mean,
to.
it's a improper one, right, though?
Yes,
And like, you don't have to always change it,
that's right.
I don't think.
Now, let's say I wanted you to add 3 fractions, like 1/2 plus 1/3 plus 1/4. There's nothing different about this except you have to find the smallest number that all of these go into.
Yeah.
And not just 2 of them, all 3 have to work. So that's really the hardest part, is figuring out what it is. It's usually a good idea to try multiplying 2 of the numbers together and seeing if that is the least common multiple. That does work here. If you choose the 2 of the 3 numbers here, it will give you the least common multiple.
Yeah, it's 12.
It is 12. And then, like you did in the previous problems, you have to figure out what number goes on top by figuring out how do you go from 2 to 12, 3 to 12, and 4 to 12.
Yeah, and then you would just multiply all those ones.
Yeah, so this is 6.
And then 4 and 3.
Okay, so let's do one more of these. And then we'll move on to something else. Okay, so give this one a try. Let me know what you come up with. Do you have an answer for me? You're still working on this one.
I'm still doing it.
Okay. Can you tell me your least common multiple, your bottom number here?
24. I'm
It is
just adding the tops.
good. Yeah, no, 24 is good. There's that's the right number.
So it'd be 9/24 and then 3/24.
The middle one, you're multiplying
Or
6
no.
by 4 to get to
Oh, 4,
24.
yeah, 4, not 3. I
Okay.
hadn't counted again. That's what I was doing. And then 3 is whatever it takes from 3. I
Yeah.
have to count it out.
It's 8. 3 times
Okay.
24. Yeah. Okay. And then when you add these up, 9 plus 4 plus 8, you get 21 out of 24. And that leads nicely into kind of a related topic here, which is reducing fractions. Okay, so while this is correct, 21/24, it's
It's
not
not lowest term. So you have
exactly.
to.
What can you divide the top and bottom by?
I don't know.
So you start with 2. You always start with 2, but neither of these numbers are even. Do you agree with that? They're both up. This one's odd and this one's even. They have to both be even. Now, divisibility rule for 3, that's either your multiplication tables or we can talk about the divisibility rule. I sense maybe a little bit of a struggle because going from 3 to 24, you weren't right on top of that one. That's gonna really take a lot of time on the test. So when I get stronger at that, try to find some things. There's actually this thing called Rocket Math. I think they've got like a free trial, but it'll get you faster with this kind of stuff pretty quick. And there's tons of apps, of course, as well. But these are actually both divisible by 3. So do you know what 21 divided by 3 is? 24 divided by 3? Okay, so that's 7 and that's 8. All right, so we're gonna work on reducing, but we also need to look at subtraction, subtracting fractions. It's really no different than adding, but you have to be comfortable doing both. So to subtract 2 fractions, you still need a like denominator. Okay, so the like denominator here is 8 times 3 or 3 times 8, 24. I'm trying to pick numbers that might be familiar now that we've done a couple of examples. 8 to get to 24 is times 3, which means you're going to multiply the 7 also by 3. That's 21. And then how do you go from 3 to 24? This time you multiply by 8. So that 2 you're also going to multiply by 8. And that's 16. So 21 minus 16 is 5 over 24. Let's have you try one here on your own. Let's have you try 5 over 12 minus 1 over 4.
Is it 2/12?
Yes, but that can be reduced.
Yeah.
Okay, and that's where I think we've got to spend a little time here. So you always start with 2, and these are both even. So you can divide both of them by 2. Okay, can you tell me what the top is? 2 divided by 2?
1.
1. Now, sometimes with division, it's easier to go and look at it another way. Like the answer down here in the bottom is 2 times some number equals 12. And these are the same. Like whatever you multiply 2 by to get to 12 is the answer to 12 divided by 2. Does that at all help to figure out what goes here?
Oh, I know it's 6. I
Okay.
just didn't know you wanted me to reduce it. I thought you just wanted me to do the other stuff.
Well, the question is, I think on the test they're going to be reduced.
Yeah, they're always reduced.
And it's rare when you don't see it. There's some on the SAT that are not reduced. I don't know why. They do that. It's so sorry. So here's a new problem to look at. I just want you to try reducing this fraction. Does 2
Is it
go in?
3/5?
It's 5 over 3. 5 over 3, because 10 divides by 2, and so does 6. Maybe there was just a mix up with the top and the bottom. So let's have you try another one here. How about 28 divided by 8? Same instructions here
Oh,
too.
I was trying to find the same, I was only looking at the first number. I was thinking it was 5/6 and 10/3. Or no,
Okay.
I don't know what I was thinking, but I was trying to find the least common multiple of 10 and 6 for some reason instead
Okay.
of 6 and 3,
Well, yeah, I mean, and it's good that you
which was
found it.
30.
It is 30. Yeah. And so, I mean, that's good. That's good to know. It just, when you're reducing, we always want to get smaller. So give this one a try. Definitely don't want you to find the least common multiple of these two. That will take a while. Um,
What did you want me to do?
I want you to reduce this fraction. Just like in the previous problem, find out what goes into each number that's the same in the top and the bottom, and then continue until you think you have the reduced fraction. How are you doing on this one?
No, I'm still confused about the first one.
You still go, okay, so this first one's still unclear.
Mm-hmm.
Okay, let's back up then. All right. And maybe we should transition to another topic if this isn't clear, because it's but we'll so you always start with 2. You ask yourself, can you take 10 and divide it by 2? And the answer is yes. Okay, but it has to also be the case that the bottom number can be divided by 2. So it's 10 divided by 2 is 5, 6 divided by 2 is 3. This is the final answer. So let me give you another one here. Let's do 14 divided by 4. Okay, and the instruction is to say to reduce or to simplify. Okay, and you're looking for numbers that go into both 14 and 4. So does 2 go into both 14 and 4?
Yeah.
And it does. The reason is they're both even. They're even because it ends in 4. So you can divide both of these by 2. What is 14 divided by 2?
I'm not sure.
Okay, it's 7. How about 4 divided by 2?
2.
2. Okay. Now you try it again. You're like, well, is 7 divisible by 2? And the answer is no, it is not. It's odd. 2 is divisible by 2, but they have to both be. Okay. So you stop reducing, and I can tell this is unclear, but you stop reducing when you get down to numbers that can't be divided any further. I would like to look at some other problems that don't involve reducing, because I think we're getting stuck on something that will eventually get cleared up once you've done a little more math. Your number sense will get better. How do you feel about word problems?
I think I like to stick on the reducing.
You want to do some more reducing? Okay, let's do that. So you try the number 2. You always start with 2, like that's your first guess. Okay, so let's give you a new one here. Let's say it said to simplify or reduce 18 over 4. All right, and you always try 2. Are these both divisible by 2? Is 18 even?
Mm-hmm.
And is 4 even?
Mm-hmm.
Yes. So that means you have to divide both the top and the bottom by 2.
I have more of a problem when they're not, because usually I'll just cut them in half, but
Okay. Well, so we're building up to that. So like let's say, let me give you one here. It says simplify 21 over 6. Okay, this is a reasonable problem for them to put in front of you. So you try 2, but 2 doesn't work. Okay, so the next number you try is you try 3. 3 is the second prime number. Now, the divisibility rule for 3 says you take the number and you add up the digits. So you add 2 plus 1, which is 3. And if that's a multiple of 3, which it is, you know that 3 works. Okay. We also know that 6 works because 6 is a multiple of 3. It's 3 times 2. So that tells you that 3 works. And now you have to be able to divide. You have to be able to come up with this result here. So 21 divided by 3 is 7. 6 divided by 3 is 2. And that's your final answer. Let's try another one. Let's look at another one here. So let's go with 42 over 33. Okay. And it would say to simplify. So you start by trying 2, but the bottom number is odd, so that doesn't work. That's out. So now you say, okay, well, let me try 3. Okay. If you're not sure, you have to use the divisibility rule for 3. So the divisibility rule says you take the number and you add up the digits. So 4 plus 2, which is 6, that's divisible by 3. If the sum of the digits is a multiple of 3, then you're in good shape. Same with 33. 3 plus 3 is also 6. That's definitely a multiple of 3. So you divide both of these numbers by 3. And that's, again, that's maybe where this, there's a bit of a, learning curve here to get you caught up on this. You knew this at one time, I believe you did. And same with this. I just think we got to get it, get it back to the forefront. Do you want me to show?
It's just most of times tables, the only times tables I have memorized is 9. Like 2s I can, 3s I can count, but like I have to count on my fingers. I just don't have them memorized, so it takes a while.
Yeah. And so do you want me to just give you the answers or show you how to do the long division? What would be best for tonight?
No, just give me the answers because I can't go back and forth between my
Okay.
calculator since I don't have my computer working.
Got it. Yeah. So this is 14 over 11. And this is it. This is done. Okay. It is kind of a harder task to know when you're done, but I'm trying to pick problems where there's just 1 or 2 reductions here for this. So here's another problem. Let's say it's 85 over 15. And they asked you to simplify. So you try 2, but they're not even, so that's not going to work. You try 3. 85 is 8 plus 5, that's 13, which is not a multiple of 3. That's no good. So now you try, the next number you try is 5, and these are prime numbers. Do you remember the divisibility rule for 5?
No.
Ends in 0 or 5. So if the number ends in a 0 or a 5, it's divisible by 5. Does 85 end in a 0 or 5? Yes. How about 15? Yes. So these are both divisible by 5. So this ends up being 17 over 3. So it's an iterative process. Like you start with 2, then you try 3, then you try 5. You shouldn't have to go much past that. Like this is not, they're not testing your ability to like reduce extremely complicated fractions. But what could happen is you could have to do more than one of these in a problem. Okay. So it might be like something like try 18 over 54 to reduce this. It would say to reduce 18 over 54. So you try 2. Both of these are divisible by 2. 9 and 27. But now 2 doesn't work. Okay, 2 doesn't work because they're both odds. So you're like, all right, done with 2. Now let me try 3. Now, does 27 divisible by 3? Well, if you're not sure, you take 27. All right, let me add up the digits. 2 plus 7. Oh, that's 9.
You would do them both by 3.
Yes. Like even if you know the answer, this is the thought process. Even if you already know, because then it works for other problems, and then you try it again. You're like, all right, well, it worked once. Let me try it again, and it ends up reducing to 1/3.
Well, usually I figure if the top number can go into the bottom number, then it can probably be reduced again. Like 3 goes
Yes.
into 9, so there's probably another reduction there.
Yes.
Usually.
So let's try one more here. It would something like this, like 16 over 80. Do you have another idea for how to reduce this? Because I kind of heard that in the last one, like you try to find a number that goes into both.
Oh, yeah, that's why I was confused. I was doing the type of finding the number for as if I was trying to find the like as if I was trying to change the denominator and not like
Yeah,
the lowest one they both go into and not like the lowest one they can both divide into evenly, if that makes sense. I was
it, it,
doing a
it
different
does.
kind of number finding.
It does,
Instead
but
of just going by 2, 3, 5, I was like trying to figure out which number they would both go into as if I was trying to swap them because I was still on the changing the denominator thing. So I don't know if I could use that at all, but I would just,
You kind of could, like, you could tell me, we could do the 2, 3, 5 thing, or if you're like, hey, I know that 8 goes into both. We can divide by 8 to start. You don't have to do it this way that I'm showing you.
well, that's an easier way to do it because my problem would be like, I would see it. And if it was a big number, sometimes if I couldn't cut it in half, I'd be like, okay, well, do I have to just keep picking numbers or?
Yeah, so I always try to show you ways that always work rather than, maybe works in 1 or 2 problems. So these are both divisible by 2. That's 8 over 40. And then you say, all right, well, it works again. Let me try it again. So that's 4 over 20. Like, all right, well, it worked. Let's try it again. So now it's 2 over 10 and it works again. So you keep going until it doesn't work. And it could be many, many, many times that it works. Absolutely. Okay, so how about, let's try another one here. Let's try reducing 42 over 30. What number should we divide both the top and bottom by?
3 probably.
Say that one more time.
Is it 3? I don't know if 30 is even.
So it's even, I guess, sorry for not being clear. 0, 2, 4, 6, or 8. If it ends,
Oh, okay.
if
Then
it
yeah,
ends in
it's
this,
in 2.
yes. So they're both
I
divisible.
know 2 is always even, but sometimes some numbers like they're even, but like when I look at them, my head just screams that they should be odd, and it confuses me. And if I have to like count to make sure it's an even thing.
Sure.
So
Yeah. So
it makes it easier if I know it's zeros included.
yeah, like the way we would have liked you've been trained is to like only look at the last digit and you don't care what's going on before it. Unfortunately, when you're a returning student or trying to go back and do something, it's like got a lot of bad memories, or sometimes it's not a clear memory.
I tend to mix numbers up when I read them, kind of like almost like dyslexia with like letters. Sometimes like I'll be doing problems and I'll get them confused, and then I'll realize like I read like the number like from some other question or something. Like sometimes I'll just get the numbers mixed around.
Yeah.
So I gotta like read them carefully.
Yeah. I've got the divisibility rules on my website. I'll send you a link to that. These are both divisible by 2. So 42 divided by 2 is 21. 30 divided by 2 is 15. Okay. And we're in a good spot here, but the problem is 2 doesn't work anymore because the first one is odd and the second one is odd. So we know it doesn't work. It's like, well, now does 3 work? You try 3. Well, 21 is 2 plus 1 or 3. 15 is 1 plus 5 or 6. Those are both divisible by 3. 7 over 5. And you essentially stop when you have one prime number or another most of the time. But you kind of keep going until it says, well, that's probably as far as I can go. Plus you'll be looking for this answer. Like you'll be like, oh, 7/5 is on my answer sheet. Let me go with 7/5. So what I'd like to do now is look at a couple of word problems that will then utilize the simplifying that we've been doing. If you're okay with that, it's good to look at some of these that are maybe a little bit out of your comfort zone, plus some mixed number stuff as well. Let me pull that back up. There we go. Okay. All right, so let me put this in front of you. Look at it together. This seems like the kind of question that they could ask you. So we'll see here. So a patient is given 1.5 teaspoons of medicine in the morning and 2.25 teaspoons at night. How many teaspoons total does the patient receive daily? Okay, so what are you doing with these two numbers? What's the math operation between these two numbers?
Do you add the mixed numbers first or
Yes.
like separately?
Well, so we started talking about that last week. let me just write them out here. Yeah, you're going to add them together. I think it's best to convert them to an improper fraction because that always
That's what I
works.
was thinking, like with the subtracting.
Yes. All right. Now, do you remember how to convert this to an improper fraction?
You multiply two of them and then add one of them. I forget which ones you
Yeah,
multiply and which ones you add. Don't you multiply the bottom and the whole number and then you add the top? Yeah.
exactly 4 times 2 plus 1, and then the bottom number stays the bottom number. So 2 times 1 plus 1 over 2. So the top here is 8. 4 times 2 is 8, plus 1 is 9. 9 over 4, plus 2 times 1 is 2, plus 1 is 3, plus 3 over 2. Now you can find the least common multiple to be able to add these together. And I hope you'll say 4. So will
And
you
then
add?
you would change the tops too.
We keep, yeah, the one on the left, we can keep the top because it's already
Yeah,
4.
because that's the same.
Okay, but what do we do on the right? What do we do to that 3?
We change it to 6.
Exactly. So we add them together, 15 over 4. So this is where it's like, well, can we reduce this fraction? Maybe this is where you've been struggling in the past. Okay, so let's see here. Does 2 work?
No.
Nope.
And then
3,
3 doesn't because 4 is not a multiple.
right? So
And then so you'd
you
go to 5, but 5 wouldn't work, right?
and because you've gotten past this number, you can then stop.
Okay, so once it's something that's higher than 4, I would know that it's
Yes, and
so
or looking at the answer, noticing that one there. Yeah.
and then I would just turn that back into a mixed.
Maybe. I mean,
I
we don't
mean,
know.
I don't know if like I'd have to because technically both would be correct answers.
Yeah, like
I
if
guess
you
it just depends.
in college algebra, this is preferred.
Okay, that's interesting.
Once you get, it's like they tell you the wrong way, and then they say, "Oh yeah, we didn't mean that." Anyway. All right, let's look at another problem here. Another one of these word problems. All right, so let me frame this in the screen a little better. All right. 3 1/3 feet are cut off a board that is 12 1/4 feet long. How long is the remaining part of the board? Sometimes a picture helps. The board is initially 12 1/4 feet long. And then they're cutting 3 1/3 feet.
So could I do the same thing and turn them into improper and then subtract the 3.5 or 3 1/3 from the
Yes, exactly.
1 and 12
Yeah,
1/4?
yes. So exactly what you said.
So it'd be 10 over 3 would be the 3, and then I have to do 4 times 12.
That's 48 plus the
Okay.
1 is 49 over 4. So I'll help since, they know you got to switch screens with the calculator. It's not ideal. It's going to be 12 and 12. I didn't realize this one got so large, but 49 times 3 is 147. Just show that here, times 3 times 3. And 10 times the 4 is 40.
The 40, yeah. That one's easier.
Yeah, that one's nice. So this becomes 107 divided by 12, and we'll just call this the final answer. I believe 107 is prime.
Yeah, because those can't be reduced, right?
Yeah, I don't believe so. Okay, let's look at one more for maybe transitioning to a new topic. Maybe this one I think you could do on your own. So I'd like you to give this a shot. Ask me some questions if you have them. Have any?
Is it 5/8?
Yes.
Okay.
Very
And
good.
then that's can't be reduced either, right?
That's it. Yeah, because there's nothing that goes into both 5 and 8.
Yeah.
The only thing that goes into 5 is 1 and 5. All right, so another task that I think we could look at here is we didn't talk about ordering fractions. So like, for example, let's say I asked you, I gave you 1/3, 7/8, and 1/2. And I wanted them ordered from smallest to largest. So to do this, you have to make a common denominator like we've been doing when you add. What is the common denominator in this case? What's the least common multiple of 3, 8, and 2?
8,
So
right?
it's like multiples. It's
Oh
like
wait,
3,
never mind.
3,
I
6,
forgot about
9.
the 3.
Yeah. I'll help here. It's 24. So you have to replace each of these fractions, change them into the new denominator. Is it clear what I'm asking for? Okay. So the first one is 8. This is 21, and then this one is 12.
Oh, is you do the same thing?
You have to do it for all 3 of them. Now you have to order them. You have to say, okay, it's, oh, okay, 8/24 is the smallest, then 12/24, and then 21/24. That's not very hard to do once you have the numbers.
Mm-hmm.
The thing is the answers are going to be in terms of the originals.
Yeah.
So
So
you have
you'd
to
have to remember which is which.
you have to map them through the entire process. You say, oh, that's really that one, and the the 1/2 is really the 12/24, and so on. So you'd want to give your answer that way. You'd say, okay, it's 1/3, 1/2, and then I think 7/8 was the last one. So here's one that's just it's got a few more. It's got an extra number in it, but I think it's a little bit easier to find. Let's look at this one together. That least common multiple is going to be really helpful if you can figure that out here. What is the least common multiple among these bottom fractions? The 10, the 4, the 2, and the 5.
Is it 20?
It is 20. So we'll put them all over 20. And can you tell me the new fractions for each of them, please?
The 7 would be 14.
Good.
$15 over 20 would be 3.
Good.
And then 7 over 20.
You're talking about for the third one here? You're multiplying both of them by 10.
Oh, never mind. I was looking at the 7 instead of the 10 when I was looking back at the other one. I couldn't remember because I remember it was the flip of another one. And then
How about the last one?
12.
Yes, okay. So the order is 10 over 20, 12 over 20, and sometimes you can even cross them out as you go, 14 over 20, and 15 over 20. But what does that correspond to in terms of the originals? I mean, that's really the core thing here. It's like, well, which one was the one, or which one was the 10 over 20?
So half would be the biggest,
Good, the smallest.
and then, oh, we're going smallest.
Yeah, smallest to largest.
Oh, I thought we were going largest to smallest. So half would be the smallest, and then the 3, and then,
3/5.
or I
Yep.
mean the 5, the 3, because they're two of them are 3, and then the 4, and then the 7, 10. I
So
think no, the
four-
3, 4, and then the 7, and then the 3, 4.
Yeah, it's almost like there's a path backwards. You're like, oh yeah, it came from, that's the 7 over 10. And then the 15 over 20, you're like, oh yeah, it's that one. And then that was really the 3/4. Okay, so let's do some multiplication with fractions and maybe some division. I know we covered this a little bit last time. Let's say I want to do 1/2 times 4/3. Okay, so we're going to multiply fractions. We're switching topics. When you multiply fractions, you multiply the tops, and then you multiply the bottoms. Now, I know it's usually, you probably seen this in books, numerator and denominator.
Mm-hmm.
They're just, those names exist just to represent the top and the bottom. That's all it is. So if you prefer top and
Yeah.
bottom, use that. They don't actually mean anything else. So if 1 times 4 is 4, 2 times 3 is 6. Can you reduce this fraction? Does 2 go into both 4 and 6? Yeah, we can divide both of them by 2. That's 2/3. So here's another one. How about 7/12 times 6/7? So you multiply the
Is it
tops.
41?
42.
Oh, 42, and
over
then
over 84. Yeah, and I want to give you that because I really want to emphasize the the reducing here. So try 2. Does 2 work for both?
mm-hmm.
Yeah, it's 21 over 42. But now, can you use 2? Does 2 work in the 21?
You do 3 for both of them.
That's right. Try 3, and 3 does work in both of them. Ends up being 7 over 21. Now, does 3 work? And 7? Can you multiply 3 by some number to get to 7?
Mm-mm.
Nope. So we can't. So next one is 5. Do these numbers end in a 0 or a 5?
Mm-mm.
So the next prime number is 7. Are these both divisible by 7?
Yeah, aren't they? Because
Yes.
it would just be however many times 7 goes into 21.
Exactly. Yep. Okay, so let's talk briefly about dividing fractions because it's really multiplying, and you'll see that in a moment here. So let's say I take,
you flip it.
yeah, if it's
Okay.
written as 4/3 divided by 2/3, what you really do is you take the first one and you multiply by the flip. See how this 2/3 is flipped to become 3/2? And that's all you have to remember because you never divide fractions. Never, 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 right? But now you have to be able to multiply. So 4 times 3 is 12. 3 times 2 is 6. Now, can you try reducing this, or maybe you already know the answer?
Wouldn't it be half because 6 goes into 12 2 times?
So here's what is
no?
true. 6 divided by 2 is a half. but not the other way. When
Oh,
12 is
is
on
it
top.
because it's that way around? Then
Yes,
I'm not sure. Oh, wait,
it's-
you would just do it the same, but flip?
yes,
Oh, okay.
yes. You were right. You like, it was just, you're so close. I didn't want to just say, hey, no, it's because it wasn't wrong. It was really close. We just got to get it. Get it. So let's do another one here. Let's do 5/6 divided by let's go 10 thirds. Okay. So what would this become? Which one do you flip? Is it the first one or the second
The
one?
second one, so it
Yes.
would be times 3/10.
Okay. So we're going to multiply the tops. 5 times 3 is 15.
15, and then 60.
Yeah. So here's one to reduce. It's like,
You could do 5 for those.
okay. So that's 3/12. You actually skipped 3.
But there's 3 too, because it could
Yes.
be the same could be done for 3.
Exactly. Really good. Let's try one more here. Let's go 3/4 divided by let's go 9/12.
So it would be 3 times 12.
Good. 36 over.
They're also 36.
Yeah. So what does it mean if you have the same top and the same bottom? Do you remember
Doesn't
that?
that just make it a 1?
Yes. Very good. How do you feel about fractions right now?
Okay.
I think you did great. I think you really are understanding. I mean, you're working through all the problems. Have you tried any of the problems in this problem set yet on your own?
A couple of them, some of just the